Connecting to cloud server. Okay, yes, so it's recording. Yeah.
Okay, so let's get started. Thank you. So dear colleagues and friends, good afternoon. We hope you are well, and welcome to our AI seminar series today. I'm Wei Feng Chen. I'm the coordinator of our AI seminar series. So on behalf of our AI Research Center, I hope you are all well and excited about today's event. Today, we are very excited and to have our colleague, Dr. Maysam Abbod, as speaker here to give us a talk on applications of artificial intelligence. Maysam is a reader in intelligent electronic systems at the Department of Electronic and Electrical Engineering in our Brunel University, and also as a member of our AI Research Center. Maysam has actively pursued research in the field of modeling systems and control engineering on many industry projects for more than 25 years, has published over 150 papers to date, and filed a patent application. Very impressive. Maysam's recent research work is dedicated to the use of artificial intelligence for machine interfaces, such as text recognition and classification, and gesture recognition. He has been involved in several research projects funded by British Council and EU, and he has supervised 35 PhD students to completion, and currently working with many PhD students in the use of AI in many fields. So here, I'm now handing over to Maysam now. Here we go.
Okay, thank you very much, Wei Feng. Good evening, everybody, and welcome to this talk. I will not be able to look at the charts if you're going to put any messages there for the time being, because mostly the screen is covered with the PowerPoint slides. So if there are any questions, do excuse me if I don't look at them for the time being until maybe to the end of the presentation. So today talks is going to be dedicated towards the application of artificial intelligence. And we know this is a very active field as it happened now, and lots of people are talking about AI all the time. The government is talking about AI. Lots of companies are working on AI for the time being as well, and then they are thinking this is the future. And this is the main essence of the talk is where are we in terms of applying AI to our life or to our applications, wherever it's been applicable. So we can see that AI is mostly evolving nowadays, and it's been always used for lots of applications, mostly technology application, business, and lots of government places or government organizations are basically looking at AI as the solution for the future. And you can see in the news, mostly they are talking about AI. We're going to apply AI here, we're going to apply AI there, and it's going to be the solution that's going to solve the problems for us. It does solve the problems for us, but we need to know what's AI to start with, and we need to know what tool to start to use in order to solve a particular problem. So it's not like one solution solves all. It's really a platform that has many tools inside it, and this platform basically we need to know what kind of a problem, so we can apply the tool, the appropriate tool for that particular problem in order to solve it. So now all the people are thinking the future will be AI. Everything in the future will be using AI. But is it really in the future? Which I don't think so, because if you look around us, that most of the applications that we are using now, it uses some sort of AI system, whatever it is, on your phone or on the computer or in the communication system that we are using, or even maybe in the shopping or advertising fields. All of them are using AI, but really we don't know they are really using AI, because the field is emerging and lots of people are knowing the term AI as a very general term, and you wouldn't know what's behind it or what type of algorithm they are using in order behind that type of application in order to solve the problem. So the point here is that the AI is the present, it's not the future. The future will be a bit more different. I think it will be more AI oriented, that's no doubt about that, but it will be more sophisticated. And I think we're going to reach to an era where things that we saw in the past as science fiction, but it will be happening in the future soon, because all the applications around us are basically using AI. So what's AI to start with, which is, of course, it's artificial intelligence. And lots of people know it as AI. But of course, it's a technology that is based on a computer science or a branch of computer science. And it uses machine intelligence in order to learn from the environment the way we do learn from the environment. Because as a human ourselves, we do learn from things around us, and we adapt ourselves to live or to develop tools or mechanisms in order to make our life easier. So if we look at Facebook, I think it uses applications of artificial intelligence, and that all based on something like image processing, even sound processing or voice processing, all these type of, or speech processing, all these type of applications that Facebook are using now in order to direct the right advert to you. Because if you think of Facebook, it's a commercial platform, and the main purpose behind it, although everybody uses it to watch videos, but the main purpose behind it is for advertising. So if you want to buy some space on Facebook to advertise your product, it's going to be expensive, of course, because it reaches to everybody. And the way they've done it basically is all due to the AI algorithms that are basically running behind the scene, which we don't see, of course. And what they do here, they look at your behavior, they look at the type of things you are interested in, the type of videos you watch as well. All of these basically will dictate what type of products that you are interested in. And based on that, they will send you these type of adverts. Because once you log into a certain site, in a few minutes time, you're gonna receive these adverts about selling this, selling that. Sometimes even if you are saying a word, which are basically, for example, if you are discussing with a colleague about a particular product, sometimes these computers are listening to us as well in the meantime. So we don't know that, but they usually do. And these companies, once you sign up for an account with them, basically you sign up your rights, and basically they are using all your data in order to do their marketing. And that's how they make their money, basically, because their platform is basically a commercial platform that basically sells products, as it happened there. So things are advancing, of course, and all these algorithms used to be there on the platforms before, but it wasn't known as AI because usually they don't announce that. They usually tell you that we have some algorithms for analyzing your behavior, for analyzing your voice, maybe analyzing your images that you're looking at or whatever. But in the meantime, I think it all been developed in the past century using AI techniques. And it wasn't known as AI, it was known as maybe intelligent systems, or it was known as smart systems or whatever. But nowadays, it's mostly known as AI. And that's the well-known term that lots of people know about. So if we look at these type of applications, like what we have here, let me point to options so I can, get there. So for example, we have lots of technologies available nowadays. Siri, which is on your phone, iPhone, Alexa, which is basically you can buy from Amazon, or Watson, which is the Microsoft. All of these are products which are based on AI, although it doesn't announce it, or it doesn't basically say that these are AI, but we know that all of these applications are based on AI. And these are the people who have commercialized these type of products, AI products or AI tools, as it happened, in order to make it useful. In the past, it was, I think, mostly academic research, which people are doing research in the universities and the certain companies to use them, but it was very limited in terms of the use. But nowadays, it's very well known because these companies, which are basically commercializing these, they made these algorithms available to people. They made it freeware. Once they made it freeware, people will start using them, downloading them, and using them as their tools, basically. So we hear also about part of the AI, machine learning as well. So this is a technique that how the machine learns from the data which we have. So the way we learn from data or from the environment around us, basically we monitor and then we test or put hypotheses, and based on these hypotheses, we will make decisions. And this is basically learning, if you think of it. So according to Herbert Simon, he defined learning as a process of which the system improves its performance from experience. And this is what we do as a human. We learn by experience. So if somebody makes a mistake, he will say, I learned from my mistake. I'm not going to repeat it in the future, which is basically that's learning as it happened there. There is another definition, which is about machine learning by Tom Michel. And it's a study of algorithms that improve their performance. And the performance is defined by P at some task, which is T, with some experience. So you have the experience, you have the task, and you improve the performance based on that one. So you have these three elements, which is the performance. That's something which you want to develop. You have the task, which you are after, which is to achieve, and the experience that you're going to gain from learning, basically. So these 3 points are the main pillars of the machine learning. You need a performance, a task, and an experience. In the past, I think lots of algorithms were used in order to learn from data. For example, if you think of a simple problem like linear regression, if you want to develop an equation to model certain type of data, what we used before, we use data, and we use the program. So basically, that's the regression equation. We feed it to the computer and ask the computer to fit the polynomials of the linear regression equation to the data. Once we do that, you're going to get an equation with polynomials, and that basically the equation is going to predict for you the output from the behavior of that data based on particular conditions which you feed it to the data. So that's the traditional way of learning. It's known as learning nowadays as well. However, the more state-of-the-art machine learning, it works in the other way around. So you feed the data, which is the same as what we fed here. You feed the output, which is what we were expecting from the system before, to the computer. And the computer will run an algorithm, and it will come out with a structure. And that structure is a model. And that model basically will predict for you the output when you're going to do the training. So in the future, when basically you've done the training, you're going to feed the data, you're going to predict the output. So what we are generating here is a type of structure, which is based on machine learning. And that type of structure basically will generate a model, and that model will allow you to predict the output for a given input. So what are the characteristics of an intelligent system or a machine learning system or artificial intelligence system? So it has these features here. It's supposed to be able to extract information and knowledge from data. So we said we're going to feed data to the system, and it's going to extract the knowledge from that data. It's supposed to reason like a human as well. So the way we think, if X, then do Y, that's the same way which the machine learning will learn. And it's supposed to learn from experience. And that's what we do with the training. So the training basically is teaching the system. And that teaching is based on the experience. So you teach once, you go back and then retrain again, and then teach again, and then go into another iteration, and so forth. So that's the process of machine learning as it happened. And it's supposed to deal with imprecise information as well. So if I feed any imprecise information which the system hasn't had before, it should be able to predict outputs based on situation which it hasn't seen before. And this is one of the good features of the machine learning or artificial intelligence system. It's going to give you output based on a situation which you didn't have before. And it's supposed to find the solution through an evolution or a neural evolution, natural evolution. And this is one of the systems which we're going to go through to tell you about what type of machine learning algorithms that use natural evolution. Applications, of course, application-wise, they are becoming very sophisticated now. So anybody can talk to his computer. I think Windows, you can talk to Windows. It can do understand what you say. Phones can understand us as well. Even when you browse the website, I think Google or whatever machine or whatever search algorithm or search website you are using, they do listen to you as well, and they do understand what you're saying, whatever language you're speaking in. They do understand what you're saying. So it's basically can process natural languages now. It can do the speech recognition as well, antithesis, and as well as image analysis as well. So it can look at an image, and based on that image, it will basically analyze what type of characters or what type of objects are in the image. Now, if you think of the theory, it's not a new theory. It's been developed in the 70s and 80s. And the first system which has been developed as an intelligence system or as an artificial intelligence system is called an expert system, which was based on rules, by the way. So you put rules in the system, and then you're going to basically solve the problem for you or do a diagnosis for you based on the rules that has been stored in the system. That all was based on the expert experience or expert knowledge. So you take the expert knowledge, put it into the machine, and it will act as an intelligent system for you. And in the 80s, this branch used to be known as soft computing, which is not many people use that term nowadays, but in the past, because it was mostly programming, it wasn't any hardware before, but nowadays they have hardware and software in the meantime, which is combined together. But in the past, it was mostly known as soft computing phenomena of applications. So an expert system basically is used to solve a complex problem for you by reasoning through knowledge. So we put the knowledge inside the expert system, and through rules, it's going to do for us the inference of these situations. So they were programmed in languages which some of you might not heard of, like Lisp, Prolog, COBOL. These are very old languages, which they developed them especially for the expert system. And I think, I don't think they exist anymore now, but it was more logical type of programming language. And lots of expert systems were developed on the time, like Maysam, which is basically a medical diagnosis system, Exon, Caduceus, and there are other systems which are basically for maintenance or basically for fixing electronic equipment and so forth. And you can see that this is one of the old expert systems that they were available. Of course, this is a computer, a keyboard, and a screen, and you can see it's a CRT screen, but it was more like a complete system that people use. So they can enter the data, and then it will give you the output, or basically whether it's a diagnosis or it's an advice on the screen. So that was mostly the interaction between the man and machine at the time. So you cannot speak to it, as we can do with the iPhone nowadays, or it cannot recognize you in terms of your image as well. It doesn't have any cameras. So what they do at the time is to have the human expert. There was a knowledge engineer. So because the human expert cannot just put the knowledge inside the machine, so you need to interpret that into something that you can program, put them inside the algorithm, and then you give it to the user. So the user will enter the conditions that he has, and basically the system will give him an advice based on the experience of the expert to start with, which is that person. So what happened here, basically, you are taking the knowledge from the human expert, box it inside the computer, and then you give it to people to use it as an expert system. And the expert system, I think they were very successful at the time, but eventually they phased out because once you use the expert system, I think this person here, which he used the expert system every day, he is going to be the expert eventually. Okay, he doesn't know everything that the original expert does, but the idea here is that this person is going to be an expert within the field that he's working with. And that's why the expert system, they were phased out, because those people, they were become the expert, and they said, I'm not going to need the machine anymore. I can do my own diagnosis instead of going through the machine or the algorithm in order to know what's happening. Okay, so most of these systems which we are using nowadays, and we're talking about AI system, the recent ones, they are all known as stochastic system. And what I mean by stochastic system, that they have some randomness in it. And if I look at this image here, and you can see a chaos in terms of the traffic jam here. And this is basically, if I distribute the car randomly in this space here, you're going to end up with this type of situation here. And you would think that randomness is no good, because basically here what you have created a traffic jam because everybody is heading in a different direction randomly. And this is not the way of these system work. Of course, they're going to start with a random solution to start with. However, after a while, after training, they're going to orient their system inside inside the system in order to work out a solution based on the initial stage which they have started with randomness. And randomness here, I know this is not good for the traffic, but randomness for these type of system is good, because you are basically trying to search an area, a space for a solution, or trying to search or trying to develop a model inside the space. If you don't have randomness in that space, which covers the whole working space, you wouldn't be able to cover the whole workspace. And that's what the stochastic system will be useful in terms of starting the learning, or starting, if you want to, basically for searching for a solution for a particular problem. So all of them are stochastic. All of them are basically based on randomness. And this randomness is useful rather than creating problems for us. And the more randomness, the better, I think. And this is something which we will see with the type of system that we're going to look at. So what are the algorithms available? So I can branch them into two types of algorithms. Modeling algorithms, which are basically most of the algorithms that people are using on the web pages. For example, they are looking at your voice or your image, or listening to your behavior, or whatever you are doing. So these are mostly modeling algorithms, and they are used them for prediction, for a classification, basically. So if you are doing some shopping, they're going to classify you as a person who are interested in certain type of products. Pattern recognition, which is basically to recognize an object in the image. Time series prediction, which is basically for predicting the future. Image recognition, which is a lot being used nowadays with cameras. Speech recognition, which we have on our phones as well already. Of course, some of the recent cars or the more luxury cars, they have speech recognition as well. So you can talk to the car and it will do things for you while you're driving. The other type of algorithms which are available are the search algorithms, and they are a bit different. They are, in terms of the structure, they are unlike the modeling algorithms. They are based on evolution, and some type of them are basically based on nature. So these type of algorithms, they are used for search. Like, for example, if you're searching for parameters to optimize your system, optimization, whatever you are doing, pathfinding, and this is something which a lot of people are using nowadays. And if you think of Google, the Google map, basically it's going to take you from one place to another, finding the best path for you. And this is basically pathfinding, if you think of it. Scheduling as well, that is something which is a lot of people are using nowadays in order to optimize their factories, or to achieve the best optimum solution, or best optimum utility of their system. And system tuning as well, which is maybe you have a type of machine that you want to tune, for example, a car engine that you want to tune in order to make it give you the best performance. So all of these are basically based on search algorithms. And I'm going to give you a small taste of what the type of algorithms are available, because this is important to know what type of algorithms are available in order to see what type of application that you're using. So one of the popular ones, which are basically most of the people talk about now, it's a neural network. So all these deep learning algorithms which are available nowadays, or AI, let's call them AI, although it's a general term, are based on a neural network. The recent ones, which are deep learning, it's an enhanced version of a neural network. So We'll see why it's called deep learning, but it's a neural network if you think of it. In the past, there were a few other theories available, like fuzzy logic, neurofuzzy system, which are basically developed in the 70s in order to deal with imprecise information. And there are other more like other algorithms like the support vector machine. That's again, it's another learning machine that has been developed and it's basically used for classification. And there are some theories based on statistics or probability, like the Bayes theorem and the decision trees. All of these type of algorithms are available in the past, so they are not new, by the way, apart from the deep learning, which happens to be developed in the last 10 years, but the others are much earlier than that. So lots of people in the field, they know about these type of techniques in the past, and they use them to mostly, basically, it's for academic research. So we talked about neural network, and let's look at the history of a neural network. So it's been developed early in the 40s, which are basically, if you think of that one, it's like 80 years ago. And 80 years ago, computers were not that good at all. So, well, they didn't exist to start with. I think it was mostly analog computers. And it started to develop in the 50s, like the perceptron, Adeline in the 60s, and then the disaster happens for the neural network when the XOR problem was presented to it and it couldn't solve it, basically. So this is an XOR problem. You have 2 zeros and 2 ones. And basically, if you have a normal problem like the OR problem, you can branch these two together or group them into one group and this one into one group, and that could be solved with a neural network, simple neural network like this one there. However, for the XOR, I cannot basically use this network to solve this problem because I have 3 groups as it happened there. So this is one group, this is one group, and this is one group. Although those 2 groups are one, but I cannot join them together. Unless if I have a very complicated shape that goes from there all the way around this and come back here. And this wasn't possible to solve it with a simple neural network. And that's when the neural network was killed, by the way, at the time, in the 70s. Until the 80s, they came out with the multi-layer perceptron. And the trick behind that is that instead of using a simple network, they introduced another layer inside it, which is called the hidden layer. And that solved the problem. That layer here allows the connection of this point to this point around these 2. So I can generate a shape that goes around this group by introducing this layer. And this layer basically was the hidden layer, which made the neural network more popular again. And you can see the support vector machine came afterwards. And nowadays, which we are using, which is the deep learning neural network. And you can see it's been developed through the years. And I think there are more things coming up after or recently in terms of the deep learning algorithms. So all of these are basically developed through the time. And as you can see that as we go along with this time span, the computers were developed further and further. And because these systems are very complicated, so we're going to need very complicated or very high powerful computer system to solve these problems or to execute these algorithms. So a typical neural network would look like this. So you have an input layer, you have an output layer, and you have the hidden layer. And basically, we feed the information here, and we try to configure this network to map the inputs to the outputs. And inside each of these neurons is basically what we call it as an activation function and a summation function. So all these inputs come through, summed up, scaled by a function, and then it goes out to the next neuron. As you can see here, that these links between these neurons, they have weights in them. And you can see here the weights here as well. So the main idea behind training a neural network is to adjust these weights only, nothing else but the weights. So the structure is fixed, the inputs, the hidden layer, the output. The only thing which you change are the weights, which is basically the connection between these neurons. So if I have a relation, which basically to describe a certain part of the system, using this neuron, it's going to have some relation between the inputs and that neuron. And then you go to the next stage, and then again, that neuron will have a relation between these neurons and then the output and so forth. So this is the main idea behind the neural network and how it works. And as you can see here, it's a single layer, hidden layer. And they used to use what we call it as the back propagation. And the back propagation is basically, we train the network adjusting the weights here first, and then we go to the next layer or the first layer. So basically we're going from the output to the input, and that's where the term came from, which is back propagation. I think people are still coming into, okay. So these type of algorithms did work at the time, but the problem is that once you come and increase these number of layers, hidden layers, the network wouldn't be able to work anymore. It's going to be a bit more difficult to tune these parameters or these weights to make the system learn. And until somebody came out and then they developed a new algorithm, which is basically looking at the relationship between the weights and then the change of the weights. They came out with the new algorithm, which basically based on deep learning. So some of the application which we used to use with the neural network is signal processing, of course, but I cannot just feed signals to the inputs of the neural network. It doesn't work. So in the past, what we used to do before is to take the signals, feed them into feature extraction algorithm like FFT or wavelets or EMD or powered spectral density, and then take the features out of these and feed them to the neural network. And we can learn or train the neural network in order to classify these type of signals. So we usually have two stages. The first stage, which is basically feature extraction, and the feature extraction was going to a simple neural network in order to classify or organize the network. So when they came out with a new algorithm and they could possibly now make the network learn with multiple layers, and that's when they developed a new algorithm, which is basically to look at the rate of the change of the weights with respect to the error. It's a partial derivation of the weights to the error. So they were able to train multi-layers or multi-hidden layers in the neural network in order to make it learn. And that's when they came out with the deep learning. And the deep learning is basically based on multiple layers of the system. Remember that we had a neural network here, classification, in the past slide, and feature extraction algorithm here. So what they did now is to put the whole system as neurons from the start till the end. So it was all different layers of neurons. And you can go up to, I don't know, 50 layers or 100 layers inside the neural network. And all these layers are basically trained using the new algorithm, which is basically capable of teaching a multi-layer network. And that's what made the deep learning possible. And that's what they are using nowadays. But as you can see here, multi-layers, that means multi-calculations. Multi-calculations means longer training time. These algorithms become very computing demanding. So they need very high performance computers in order to train the system with these type of multiple hidden layers. And that's why some people nowadays, they need the GPUs, which are the graphical processing unit, in order to train these type of systems. And they do take hours, by the way, to train, unlike the old system, which because they were very simple as it happened, and make the things much faster with the GPUs. So in the past, we were using types of networks, and there were two types, basically, one which is called supervised, and the other one which is unsupervised. The supervised one basically look at the inputs and the outputs of the data in order to generate a model, a neural network model, which links the relationship between the input and the output. And some of these examples, like the multi-layer perceptron, feed forward, the RBF, and the recurrent network, and the other types, which is the unsupervised learning. And the unsupervised learning is based on the input side only. You don't look at the output. You just group the data into clusters in order to generate a model out of them. And some of the models were available, like Cohonen, the self-organizing map, and the Hopfield network. But the newer algorithm, which are basically based on the deep learning, we can see something like the CNN, which is the convolutional neural network. RNN, if you look at RNN, it's the same. So it's the same model, the same structure, but it's much deeper in terms of the hidden layers. There are new ones which are coming through as well, like the LSTM, and that basically look at the behavior of the system with time. You only look once, YOLO. Again, that's for used for video image recognition. Extreme learning machine, which are the latest one, which are being developed. There are other types like the encoders, the deep belief, the transfer learning. The transfer learning is a phenomenon that people are using nowadays, which are basically, instead of starting with random weights for the neural network, you can start with a preset weights for the neural network. And you transfer these weights into your neural network, and you start from a sort of learned network rather than starting from scratch. CNN basically is used for image classification, and there are new ones which are coming through the market, like darknet or densenet. I was laughing when I heard darknet. I know darknet is basically people who are using the net, which they don't know, which they don't want to know who they are. But nowadays, people are using different names anyway. So the latest type of CNN is called darknet. These types of network, you would know them as AlexNet, TensorFlow by Google, Alexa, which we are using inside the Amazon platform. All of these are based on these type of algorithms, by the way. So these are the latest type of algorithms that are being used in the industry. The fuzzy logic, something which we talked about at the beginning, and basically it helps to interface the imprecise of the knowledge and the way which we think with the machine. So the machine is very precise, while ourselves are very approximate. So I don't say that I'm going to go 95 miles per hour. I'm going to say fast, which are basically not very precise. And this is a sort of theory that's been developed in the past as well by Lutfizadeh in 1965. And he worked on that one as a system to deal with imprecise knowledge. So this is another type of modeling techniques available. Other techniques like support vector machine. So you are aiming at classifying the classes and keep them as at a distance. Decision trees, which are basically, it's like a tree. So it's really a tree, upside down tree. So this is the last outcome, and then you go into branches. And the Bayes theorem as well, which is another theory that is based on statistics. So all of these basically are known now as artificial intelligence now. As for the search algorithms, again, there are stochastic algorithms, which are based on randomness, and they are the traditional algorithms as well. And there are some enumerative algorithms as well. So the arithmetic techniques, which are basically based on mathematics, which are developed in the past, we are not really interested in these. We are not interested in the dynamic programming. We are interested in the stochastic systems, which are basically based or known as artificial intelligence. And you can see the type of systems which have been developed, like simulated annealing, smart intelligence, swarm intelligence, evolutionary computing, which is based on GA, and even genetic algorithm. It has different types of algorithms which have been developed. The swarm intelligence is based on, so the evolutionary algorithm is based on the genetics and based on evolution, while the swarm intelligence is based on nature. So we look at how bees behave, or ants, or animals, herding animals, or Firefly, and then from there we can develop an algorithm that basically used for searching. So these are, all of them are search algorithms. So the genetic algorithm is basically an algorithm that uses evolution. So what you do here, you take the chromosomes, you mix between the chromosomes from the father and the mother, and you generate an offspring. If you think of these as solutions, and we're generating an offspring, the offspring is another solution that comes from the mother and the father. If I have a part solution in the father, a part solution in the mother, if I mix them together, I'm going to get a better solution. And that's the main idea behind the genetic algorithm. And that's when they develop the algorithm. So they have operators like the selection operators, the crossover, the mutation. And we know mutation is something that happens in nature. And it could be good, it could be bad. But again, it's part of the algorithm, which is you do crossover and you do mutation. Other algorithms like the ant colony, the bee algorithm, the PSO, bacterial foraging, all of these are based on nature. So we can look at what animals or what insects are doing in nature, and we learn from their behavior. And based on the behavior, we can generate algorithms. And these algorithms are basically used to solve problems. So the ant colony, which is basically one of the algorithms, and it's based on ants moving from one place to another. So they move from their nest and they go and look at, from their nest, they look at a path to go and select their food and come back. And the way which they do here, when they move, they leave pheromone behind them. And the stronger the pheromone, the more ants will follow the path. So basically what we are doing here, we are finding the right path or the shortest path between the source and the destination, which are most of the insects are following. And that's the idea behind the algorithm. And people have used it in order to schedule problems or schedule connection between points. I think nowadays even people are using it for communication systems. So if you want to communicate from A to B through different nodes, what you do, you need to find the best path from point to point, which is the least congested and then the fastest without any data drops. And based on that one, we can use this type of algorithm to do that. Even supply chain management as well, which is lots of people using nowadays, and the fleet management. And I think Tatiana will talk about the supply chain management using ant colony in 3 weeks' time. So something to look for as well in the future. The bee algorithm, it's a bit different. So here what we do is, again, they use the same phenomenon of which the bees are using. So the bees usually, they start from their hive and go and collect nectar from the flowers and come back. And when they come back and then they land in the hive, they will do what we call as a wiggle dance. So the bee will move around and then wiggle here, and then move around and wiggle again. And they found out the angle between the wiggle and the north, which is 20 here, it's the same angle between the direction of the sun and the flowers. So basically the bee is telling the others that this is the way to go, that direction. And how far is that? It's the number of wiggles that they do. So the more wiggles the ant does, the further the distance is from the hive where the flowers are. So basically it's a kind of communication between the ants in order to go and collect the nectar. Again, they use it for the same application, communication network, supply chain management, and fleet management. So it's the same behavior as it happened, which are basically we are learning from insects. Similar things with the birds when they fly from north to south and south to north in the winter and the summer to go and look for food and cooler climate. Again, there is a leader to these birds. This leader will always lead the others behind him or behind her, depending on who they are. And that bird has basically know the way from A to B. And if we assume that each bird is a solution, all the others will follow the best solution as it happened. And if we are searching in a search space and we are looking for the maximum point, basically that bird is going towards the maximum point because it knows the solution, and the others will follow it, which is what's happening here. It's very simple equations, 2 equations, and it's very efficient and fast algorithm. They use it again for searching, optimization, parameter fitting, system tuning, all these type of algorithms. Similarly, the whale algorithm, which is again the way the whales they catch their prey is basically to go into a circle and create bubbles, and they confine the fish within that spiral, and eventually they will go and start eating the fish, of course. So the idea here is that the global solution is in the middle. So you go around until you reach the best solution as it happened there. This is another algorithm, which is basically based on the Firefly. You can see these insects, which they make patterns in the sky. Similar-wise, the birds, which they make patterns, the phenomena behind them, they do make patterns. They fly as a swarm. They don't collide. And they basically keep distance between them. So again, it's the same concept that people are using to search for solutions. again, you develop an algorithm for that one and use it as a search algorithm. So what are the applications of these? So the swarm intelligence basically used for process optimization, navigation, inventory management. You can use it for supply chain. All of these are basically, you can use them for the swarm intelligence because it's a search algorithm, simple, very fast, and effective as well. So we go to the application now. So I'm going to look at these type of applications and link these algorithms or these tools which we have looked at so far to these type of applications. So we're going to look at banking and finance, healthcare, retails, manufacturing, e-commerce, telecommunication, marketing, education, human resources, and travel and scheduling. So computing is one of the problems that people are using nowadays, artificial intelligence, to solve. So they are using them a lot in data centers in order to reduce the amount of traffic that goes to the center, data storage, power consumption. All of these basically are parameters that you need to optimize the performance of your data center in order to get the best out of it. So you need to do communication, the optimal communication solution. You need to balance the load between the different cores in the data center. You need to divert traffic if there is something happening there. Compress data as well, which is another technique that people are using AI. And sometimes you need to extract features from your data in order to store the important things only. So these type of algorithms, which are basically either a search algorithm or a deep learning algorithm, are used nowadays in data centers in order to optimize their performances. Smart cars, this is another application, and we can see a lot of these applications nowadays. So Amazon, they are using their drones to deliver goods to different places. And in order to do that, they basically need image processing, pattern recognition, they need pathfinding, they need to optimize the operation of the system as well. All of these are basically based on AI systems that in order to operate that. You can see Tesla as well, it has some sort of self-driving. Again, they are using these type of algorithms to find the best path. And of course, because these are electric car, they need to make sure that this car will go on a path that has charging points in it in order to keep the car happy if the battery runs out. And of course, it will have some pattern recognition as well. So one of the self-driving cars, which people are developing nowadays, it has lots of features on it. So you'll have cameras, you have LiDAR, you have ultrasonic sensors, you have lots of systems that all of them, they need image processing, they need path planning, they need pattern recognition, they need all of these sort of application that all of them are based on AI. So if we can see the car here, it has a GPS, LiDAR, another LiDAR here, cameras, object detection. All of these informations, they need to be processed. And in order to drive the car, you're going to still need to plan the path. And that's basically if you're going to use one of these search algorithms to plan your path, you're going to need to scan your area, detect the objects, define the path that you're going to, look at what's in the area as well. And all of that basically is to find out the way the car is going. But however, you still need to drive the car. So in order to drive the car, you need to learn how the people driving the car, when they're going to apply the brake, when they're going to accelerate, when they're going to steer. All of these are AI systems that combine together. So the autonomous car is not a very simple system at all. It's a very complicated system, and it still makes mistakes, of course. But it needs a lot of AI algorithms in order to make it work. And communication-wise, we can see that happening every day in our life. Lots of phones, they have image recognition, voice recognition. They have Siri, which is to ask questions. They have even character recognition as well. So you can scribble on your phone and it will understand what you're writing. So all of these are things that are happening already. So we're not talking about the future, we're talking about the present. All these type of AI systems do already exist in our daily life to use them. Media streaming, this is something, again, which is people looking at nowadays, because most of the communication now is happening in digital wise, and it goes through the internet. So in order to do the communication through the internet, you need to put as much as you can inside the wire in order to transmit it from one place to another. So you can basically cramp more channels into the bandwidth. And in order to do that, you need algorithms basically to do the compression. You need algorithms to find the best bandwidth that you can use in order to send these signals. So all of these basically happening as well. And sometimes when you watch a video on streaming, basically you can select the resolution of that video in order to see it. So it will basically detect what type of machine that you are using to watch that video, and it will stream the data based on what you can see or what you are using. So you don't have to always send the whole data as it happened there, or the maximum resolution of the image. You can send it depending on the media that you are using. Banking, basically these are more like projects that some of my students did in the past. So they used all these algorithms we looked at, a neural network and the search algorithms, in order to predict, for example, this work here is predicting the exchange rate. This one predicting the stock market. This one predicting, again, the credit scoring for people in different places. All of these are based on AI as it happened there, which we have happening already. I don't know how to move it. Traveling scheduling. So again, it's not only traveling by airplane, you travel by car, by road. You need to look at how much fuel they are consuming, even in the sea as well, which is basically to look at the best path to go from one place to another, how to use public transport. All of these basically are nowadays used in our systems. So I think there are lots of apps available nowadays. You can ask, I want to go from A to B. It will tell you you can go from A to B using a car. It will take you that much. Walking take you that much. Bus will take you that long, and so forth. In addition to that one, there are lots of apps nowadays. If you take them to travel with you, for example, your phone, it will tell you where the restaurants are. It will tell you where the utilities available. And even nowadays, because if you go to a foreign country and you don't know the language, you can just direct your phone on the sign in the street, and it will translate it for you automatically without having to think of how to translate it or type it into the machine. So it's all image capturing, image recognition, translation, and then a display to you as well. So all of these basically are, if you think of it, is an AI type of systems which are available nowadays. HR as well. I have a few students who work in HR now, and they are basically looking at the way HR is being selected, their performances, the employees. So you look at the appraisal, you look at even when people are applying for jobs, you can rank them by machine learning instead of using the people, which are basically sometimes it's biased, but and that's what we want to avoid. So you can provide equal opportunities. So lots of algorithms available nowadays to do the ranking. And even some of the companies nowadays, they are getting rid of their staff. I know we are employing people here, but we are sacking people here to replace them by AI to replace people to do the insurance firm claims. So instead of talking to a person to do your claim, you just enter your information to the computer, and the computer will decide whether should I give you the money or not, or the insurance claim or not. Also, it's been used on video games. Lots of these games which are available nowadays, they use AI behind them. Although we don't know, all I think who the players are interested in is to play the game. So all of these are AI based. Chess, I think these are some of the games which robot games. This one, which is called The Last of Us 2, whatever that is. And even Mario. And if you think of Mario, Mario was very old. It's not very old. I mean, it's like it's been here for 10 or 15 years in the market. It was used reinforcement learning while you play. So basically, when you play, you're going to avoid traps in the play, and that's what is known as reinforcement learning, which is part of the machine learning systems. In our homes, again, you have lots of appliances which are basically using AI, smart windows, sensors, cameras. I think Bill Gates wants to put an IP address for each socket in the house as well, lighting, heating, TV, whatever. It's all basically in our homes now. So if you buy any of these in new appliances, you will have AI embedded inside them. Even the smart home nowadays, if you think of a smart home, all of these devices which are available in the house, they are connected together and they are interacting with each other based on AI algorithms. You can see lots of home appliances as well, which are using AI. So the Japanese are fond of these type of appliances. So if you happens to go to Japan, you will see that it says fuzzy logic on all of these all the appliances. And basically, they are using the imprecise knowledge that we have. So instead of putting your clothes in the washing machine and choosing the cycle, it will automatically look at the dirtiness of your clothes and will decide what washing cycle it should choose to minimize the use of water and then use of detergent. So these are some of the applications that people have developed from Japan, of course. Rice cookers, which is, I think is this one, air conditioning, cruise control, vacuum cleaners, washing machines, all these type of algorithms which are basically already exist as it happened. And these are old, by the way, these are not new. These are pre-2000, I believe, most of them. The online ads as well, that's what we usually do through our daily life when we watch or browse the internet or search for things. Basically, the internet will see what you're searching for and will start bombarding you with adverts related to what you're searching for. Lexis used one of the IBM Watson in order to basically analyze the car sale for them. So they basically arrange a machine learning algorithm to see how much one of their cars will be sold eventually. That's another application. Emotional connection requires the human spark. AI can do people can see look at people emotions as well. You look at the adverts platforms. You look at even adverts creation and management. So you don't get any adverts. You get adverts which are related to your interest. Even they look at what type of budget you are willing to spend as well. So they will send you products that are basically suitable for you. They're not going to send you very cheap ones if you are not interested, or very expensive ones if you don't afford them. They look at personalized website nowadays as well, which are basically make the website is more related to your interest. And they look at the customer engagement as well. So they look at the customer behavior and they keep them engaged by sending them the right adverts. Digital marketing, again, this is another area of artificial intelligence. So lots of people are looking at adverts, user experience, AI power chatbots. They predict the behavior of the market as well. They can even design web pages for you, e-commerce, voice search for you, and marketing, connection, curation, and content generation. All of these are nowadays based on AI as well. Social media, if you think of these very famous types, Facebook, Twitter, Instagram, YouTube, Pinterest, and TikTok, all of these are basically, they are using AI algorithms behind them in order to attract their customers and keep them engaged all the time. As I mentioned before, they are platforms for advertising. I know you are using them to watch videos, but in the meantime, they are sending you adverts without knowing, which, well, you know, but by the end of the day, you are more interested in watching the videos, but some of them might click and you might be able to buy some of these products while you are watching or browsing some of these or using some of these platforms. Security, again, and this is a big issue nowadays. lots of cameras around. If you go to London, you're going to be captured by a camera wherever you walk. And lots of people are using these to look out for suspects, look out for unusual behavior, look out for threat detection, even cybersecurity as well. So these are all based on AI, because you need to analyze these images, you need to analyze the behavior of the people, you need to analyze the basically the activities in the internet as well to see what's happening, instead of keeping people doing that all the time. Healthcare, and again, lots of people use it for DNA sequencing, cancer diagnosis, image segmentation. People were using wearable sensors nowadays, health monitoring, heart diagnosis, drug discovery, and they use GA, by the way, for drug discovery in the past, medical records as well. And this is something which I've done in the past, which are basically using an AI system to detect cancer in bladder. We looked at the DNA sequences of the person, and then we link it to that cancer, whether the patient will have cancer or not, and what type of cancer they're going to have in the future as well. So again, this is something which have been used already. At the time, I think we have developed more like a system that look at the characteristics or features of the patient, and then it will tell you when the patient will have relapse in the cancer. And you can even simplify the model to make it much easier to understand by looking at very important factors like the grade of the cancer, the age of the person, smoke, and then there is a gene called P53, which people are using in order to identify whether they're going to have a cancer or not. E-commerce, again, lots of these platforms are using AI. It's not to target you as a person, but basically to create business. It's more about business rather than looking at what you want to buy. So basically they are attracting companies to use their platforms in order to buy or sell or whatever business they want to do. So it's e-commerce rather than selling and buying things to the individuals. And again, they're going to look at these behavior of these companies or these people or individuals or merchants in order to attract them to a certain platform. Nowadays, some of the companies, what they do is they link investors with companies as well. So they look at what they are interested in, and then they link you to a type of investment or a project in order to invest your money in. But again, it depends on what you are looking for and your interest as well. So to conclude, I don't think we looked at some of these aspects in details as it happened there, but the future lies within these 4 types of development areas. So the healthcare is going to benefit a lot from integrating of all these systems together. It's not only diagnosis, it's patient management, it's patient monitoring, all of these type of things that will benefit from the AI in the future. Education, which I think we are experiencing that a lot nowadays because most of the education is happening from home. However, there are some systems available, but I think they are being developed as well, which are something that's going to happen as well, or the education is going to benefit from. Finance, again, although there are lots of algorithms available, but again, the space is wide, or space is very big for finance institutions to benefit from the AI. They can analyze the market, they can look at, predict the future, what will happen, and then based on that one, they can do their activities, commercial activities based on the prediction. Military, of course, this is something which is very important for developing basically defense system or cybersecurity system, because I think most of the issues in the future is going to be to do with cybersecurity as well. So you don't have to go and attack a country. Basically, you can attack it using their infrastructure in terms of the communication platforms and then transport or whatever. However, there are a few issues that need to be looked at as well. And I think a few of our colleagues in the group or in the center, they are looking at these issues as well. Is it a rewarding or is it a punishment for us? because some people will think, okay, if the AI is watching me all the time, that's basically, there is no privacy for more anymore. Where are my human rights? Is this something that basically we should allow the AI system to take over our life or not? This is something that lots of people are thinking of. And you can notice lots of issues are happening with especially Facebook using their platform for adverts, or using their platform for commercializing for different aspects, or maybe election, or maybe looking at events happening around the world. So these are issues which are not being regulated yet, and people need to look at that one in order to make rules for that one. And what I've mentioned in the past, or at the beginning, is it going to be helpful or homicidal? So what are we going to do with when we combine all the intelligence systems together, and we're going to create what we call as artificial general intelligence, not intelligence systems or AI in particular devices. It's going to be happening all together, connected all these systems together, and going to be basically going to generate a system that very powerful, and then it might, well, take control of our life in general, or the way we behave. I think this is the last slide, and I think I took longer than expected, so it's 10 past the hour now. But I'll be happy to answer any questions that you have. Thank you very much for your attention.
Yes, good afternoon. I would like to ask, I have some questions. First of all, thank you very much. It was really very interesting. I would like to ask, my first question is, I would like to ask, how do you think about Lisp programming? Since it's a language, it's a purely artificial intelligence language. And do you think it can play in today's world? And a second question is about swarm intelligence. If I am not wrong, it's being used in satellite constellations. Another question is how can we implement in reasonable hardware these machine learning techniques?
Yeah. So for Lisp, I don't think it's very popular nowadays, because they developed Lisp for expert systems at the time. And it's not a very conventional language. It's nothing that you can do in terms of what we do with programming languages nowadays. You cannot add numbers. You cannot do loops or whatever. It's basically all about putting rules inside the system and do the inference based on that one. So Lisp is very, very dedicated to expert systems at the time, and I don't think it's being used nowadays. And the other question which you talked about is how we can use the swarm intelligence for any particular application. It doesn't have to be satellite. Of course, these are algorithms, and they run on computers. And some of these algorithms, they do need lots of resources in terms of running the algorithm. But if you think of Siri, for example, again, it's an AI system which runs as an algorithm, if you think of it, but it runs on a dedicated chip. So your phone will have a dedicated chip for Siri only. And that's what makes it fast. I think if you install Siri on the old Apple computers, it's going to be part of your operating system, and all the Siri is going to be executed on the microprocessor, not on a dedicated chip. But the latest machines, or the latest systems, they have their own dedicated chips. Even for the voice recognition, the image recognition, all of them, they have their own dedicated chip. And these chips, they will run the algorithm for you, and it will become much faster in terms of the implementation. So you don't have to have it running on the main processor as it happened there. You can have it running on a dedicated chip on its own. And I think Microsoft, they are developing their own chips as well nowadays for neural network, for deep learning, which you can buy and use it as it is. You can just put it into a motherboard or an electronic circuit and use it, but just by programming. So there are ways to accelerate the hardware. And I did mention it was called soft computing, so it was mostly executed on the computer itself. Now it's hardware and software together, which makes it more powerful and much faster in terms of the execution speed.
Yes, but I was talking about, for instance, putting on a FPGA or something like this. I think regarding speed, there is something that needs to be done. I think if we are talking about deep learning or machine learning, or I'm talking about speed and computing resources.
Yeah, the FPGA basically it's a parallel processing platform which you can configure the way you like in order to run the algorithms as fast as you want. So yeah, by all means you can do that, definitely. But providing that your algorithm it has the capability of running parallel processing stuff. So the ant colony optimization, it's very flexible in terms of how you execute it, and you can run it on parallel platforms, and going to be much faster. And FPGA is a well-suited platform for running ant colony, for example. Other algorithms like the swarm intelligence, the particle swarm optimization, it doesn't, because it's a sequential program. You cannot run multiple sessions at the same time.
And convex optimization, is it included in this in artificial intelligence, or is it something different? I mean,
convex.
Yes.
Convex. Yeah. Yes. Well, it's an old technique that people have used in the past. So it's more like it's based on mathematics more than anything else.
Yes.
Yeah.
All right. Thank you very much.
Thank you. Any other questions that people might have? I haven't looked at the comments. I don't know where to find them to start with. Messages. Okay. Prof. Akram answer my question.
Dr. Abbod, can I ask a question?
Yeah, go on, please. Go on.
In terms of robot manipulators,
yeah.
Do you think it's, I think there's been a lot of, in terms of separating intelligence into special and general intelligence, there's been a lot of working special intelligence more. I think all the bits of working special intelligence will probably accumulate to growth in the general intelligence field as well.
Yeah.
But is there a way to approach the general intelligence field on its own? Like, would you think how humans learn can machines learn anything from how humans learn itself? I don't know if natural intelligence is sort of trying to do this.
That's an interesting question, which the way when they developed neural network, it was based on the brain to start with anyway. And most of the swarm intelligence are based on natural behavior of species in the nature. But what you're mentioning here, which is human intelligence, and of course human intelligence is much superior to species intelligence, other species intelligence, and that will be something that would be useful to look at, I think. I don't think lots of people looked at that one for the time being. And maybe this is something that is a new field that people can work on as well.
Okay, thank you.
Thank you. Akram is asking, the question is, what knowledge as defined within MI, machine intelligence, and AI, how many hidden layers do you need? Okay, the number of hidden layers is basically dependent on the problem in hand. So you can solve a simple problem with a very simple network, or you can solve a very sophisticated problem, but of course you're going to need the complexity of the algorithm in order to solve it. And what I made an example with the XOR at the time, if you want to link the 2 white points, so it's white 2 circles, and if you link them around the black circles, you're going to need a very complex shape in order to link them. So basically, that complex shape, it's going to need more neurons inside the neural network. So there isn't a rule of thumb, or there isn't a rule basically for deciding how many neurons that you need. But nowadays, it's mostly try and error. Although some people, what they have used is they have used GA to search for the best topology of the neural network in order to solve a problem. So basically what you're doing, you're optimizing the optimizer itself. So, and it's another problem inside the problem. Of course it works, but it's going to be very expensive in terms of implementation. It's going to take ages to solve the problem. Because if you want to model a simple problem, say it takes a few seconds, the GA, for example, if you have a 1,000 generation with 100 population, you're going to need to repeat that 100,000 times, which is, it's a lot basically. So it will have an effect on the execution time, definitely.
Thanks, Mason, for that.
You're welcome, Akram.
Yeah, but I mean, there's one of the follow-up questions. Thank you for that talk. In fact, that was a roller coaster of all applications. But the problem I have sometimes is that at CERN we use neural networks, which then go as inputs into other neural networks.
Oh yes, yes.
And you get this very deepened layer. You get multiple layers in between.
Yes.
And then the variables that go into other ones are already composites of other neural networks.
Yes.
And my problem always is how can you understand systematics? Because once you make a decision and you use these for classifications or something like that, for whatever processes you use them for,
yes,
you have to be able to make strong statements about whatever you're trying to look at, the problem set you're trying to solve. How confident are you that problems, that what you've used, the machinery you've used, does not contain some form of unexpected biases, which then need to be added?
When they came out with the idea of the neural network, they used to call it a black box. So you don't know what's happening inside it. All what you are interested in is the relation between input and output. And I had a colleague who used to call the neural network rubbish in, rubbish out. So he said, if you feed rubbish to the neural network, it will only give you rubbish at the outside.
Yeah.
So it depends on what you're feeding, basically. That's one thing. And it depends on how you want to understand the internal and how you want to correlate these internal variables or states to your problem. One of the systems that they are using nowadays is called the encoders, which is a deep learning, of course. So what you do, you generate a very deep learning algorithm, which has multi-layers inside it. And the way you start with a very large space for the inputs, and you start minimizing the number of neurons and start to increase the number of neurons as you go from layer to layer. And you're going to end up with the output, the same number of neurons as the input. And you feed your data. And then what you're going to get in the middle are the features which are basically you can extract from your data. It doesn't mean anything maybe, or it could mean something, which is very similar to the principal component analysis, if you think of it. The PCA basically transforms your data from one dimension to another to look at the more dense information in your data as it happened there in order to give you these features. So whether it means something, these are in the middle, or it doesn't, that's dependent on how you interpret these data or how you understand them. So sometimes it's not possible, sometimes it is possible to link them together.
I mean, certainly I'm thinking the more layers you have, it becomes really, really problematic when you think about the weights and what the weights mean and how those weights are related to your output that you've got. So it becomes really difficult for me to visualize, not just visualize, but to understand to some extent. But then if you said then, well, okay, what about, you mentioned decision trees here, and that for me is a much more understandable if you use something like boosted decision trees, which are really interesting, because there you can actually trace back and see and understand, and then try and understand biases or systematics and stuff like this. It's slightly more visually.
This problem was Well, sort of an answer by combining fuzzy logic with, because it's rule-based, with the neural network, which came with that, the system which is called neural fuzzy system. So you can generate rules, and you can use the search algorithm which you use in the neural network to fix the weights between these rules, and you eventually come out with some sort of rule base that can give you the relationship between the inputs and the outputs.
Yeah.
Yeah. Although it's limited in terms of the size, but
very good. Thanks.
Okay, welcome. Budur, if you have any question, Budur? I think you are raising your hand there, or is that?
Yes, actually. Thank you for the talk first. And at the beginning, you mentioned there are like different models that are available nowadays. Is each model is designed for a specific application, or those models just differ in the design, and then the user can choose which model to use based just on the design, not the application of that model that offers?
Yeah, it's a very good question, because I did mention at the beginning, there isn't a magic solution that fits all. So if you want to find a solution for your problem, you need to understand your problem first before anything else. And the other thing, which is once you understand your problem, you need to look at what data you have as well. So it's not just a matter of taking your data and throw it at a network in order to model it. It works maybe sometimes it doesn't work, but it's important to understand your system and understand what type of data you have, the limitations of this data as well. And then after that, you go and select the problem, the platform or the algorithm to solve it. For example, if you have a data set, which basically it's a very big data set, but if there are lots of missing data points in it, there are not lots of variation in the data, basically it's not going to be very useful to you to model. So again, it's the first step, which it's very important, is to understand your system before anything else. And there are lots of people, they think just throwing the data at a system, it will work. Yeah, okay, it might work, but is it reasonable? Is it realistic? That's the thing. Because sometimes you have data created from systems. If you don't look at the constraints of these data, you can predict anything, by the way. You can even change the input variables to values that are not realistic, and then you can predict an output and it looks fine, but it's not realistic. You cannot implement that in the system. It happens in the past. We had we've done some work with the British steel at the time, and then we were looking at the composition of the materials, the stainless steel. So there are impurities in the stainless steel, like molybdenum, chromium, chrome, carbon, or whatever. And the researcher at the time, he came out with a model and tell the people in British Steel, if you change the molybdenum by 1.1%, you're going to have this effect on the output. But they came and told him, we cannot really basically do that resolution of changing molybdenum by 1%. It's not possible. So despite the fact that his model says it's possible, in reality, it doesn't work. So it's important to understand the problem. This is my main point.
Thank you.
Something related to that.
Yep.
So basically, does that mean then your model is basically the relationship that the intelligence has learned?
Yep.
Okay.
So what you are modeling is what you are feeding to the system. So you can feed data to the system which are very precise. It can reflect all the behavior of the system. The model can reflect all of these. If I feed crude data to the system, it will only model that crude data. So you are modeling what you're giving to the system. Unlike the physical equations basically will consider all the variations in the parameters of the system, and it will give you a precise output, which is fine. But sometimes you don't have that luxury of creating a physical model of your system or a physical equation for your system in order to model it. In that sense, people are using AI techniques in order to develop models for these systems. But again, it depends on what type of data you're feeding. If you are feeding very precise data, you get a very precise model. If you are feeding crude data, you're going to get a crude model as well.
Cool, thank you.
Welcome. Sir Neil?
Yeah.
Was that you?
Yes.
Oh, okay. I can see your hand raised, so I thought somebody else.
Sorry.
That's all right. Thank you. So yeah.
It's not intelligent enough.
Yeah, it doesn't. Yeah. Okay, I think this recording will be uploaded to the platform which we have on the center. So if anybody interested in looking at the recording, by all means, we can deposit it there, and then you can look at it later on if you like. The slides are there as well already. So if you want to look at the slides, by all means, you can log into the platform of the center, the AI center, and then you can download them as well. So thank you very much for everybody to attend the meeting and the presentation, and thank you for those who did have some questions. I think it was interactive enough to, and I hope you have benefit out of it, and then it has given you some information which you might know already, but just a reminder maybe. Okay, I think, yes, we can stop the meeting now. So I'll hope you have a nice evening, and then hopefully we'll see you in the forthcoming seminars as it happens, which will be advertised as well soon. Thank you very much, and good evening, everybody.